So page 54. So we should be able to plot this pretty easily. Let me just get this done. -3, -5, 2, 0. Okay, and then this looks like a what? Oh. Or should look like a what? Parabola, okay? But this is the only table of values that we have to connect. It's not the only table, it's not the only values that exist, but we're using these, and this does have a restricted domain and a restricted range. So let's look at what's happening here. What is the domain of my function? -3 to 3, y'all agree with that? -3 to 3. And my range? -5 to 4. You agree with that? Yes? -5 to 4. Okay. And we include those. All right. So we're going to start off by plotting the same function here. So we're going to go to -3, -5 rather. So go inside here and just you're plotting the exact same thing. And when you graph it, it doesn't have to be dotted, but it's not a bad idea to maybe get your shape a little bit better, because you don't want it to look pointy. You want it to look as curvy as possible. Just do the best you can. It's not a class. So this is just your original function. All right, so we need to be able to do these 3 different ways. We need to be able to describe what's happening here. We need to be able to come up with our new table of values, and we need to be able to graph it. Okay, the order in which you do it, it's up to you. Sometimes you might not be asked for all 3, so if you need to go through the process of all 3 to get wherever you need to be, that's okay. You just have to do that on your own. But when we look at this right here, what's changing, our x or our y? Both. Okay. So what happens with the x? Okay, we're going to the left 3. So correct words is it's a what? It's a translation, good, and it is a horizontal shift. Okay, so this is a horizontal shift. Left 3. And then that -2 means that is a what? Vertical shift. What? Down 2. All right, so knowing that, you can take your original function. All right, so we've got this point that we know was at 0, 4. 1, 2, 3, 4. That's where we were. So I'm supposed to go to the left 3, 1, 2, 3, and down 2, 1, 2. There's my new point, right? So as far as graphing is concerned, the rest of the stuff just goes along with it. So I know that I have these 2 points here, right? And maybe if you go, from this point, you go to the left 1 and down 3, so you can go to the left 1 and down 3. And then you do the same thing over here because it is symmetric. Then I've got to go from this point, I go to the left 1 and 1, 2, 3, 4, 5, down 5. So the left 1, down 1, 2, 3, 4, 5. And you can graph it that way. I haven't even found my points yet, but I can graph the function. Then you got 2 choices of how you get your points. You can pull the points off the graph, or you can come up with the points from your transformation that you have up here. Either way. Okay, but if I know I'm supposed to, this is x actually becomes x minus 3, and y becomes y minus 2 from the original one. So that means I'm going to get -6, -5, 4, negative 3, 2, negative 1, 0, negative 7, Any questions about that? That's just kind of a review from yesterday. But being able to describe what's happening in words is important as well. So your words, your table, your graph. We're all good? All right. So this one here. What is changing, your x or your y? Your y. So I might as well just go ahead and negative 3 and fill the x's in. Negative 2, negative 1, 0, 1, 2, and 3. Okay, so my y, all I'm doing is multiplying or dividing the y value by a negative 1. Okay, yes, you're just changing the sign, but what it is a multiplication or a division of, actually this represents multiplying by a negative 1. So when you do that, what happens to the graph? What is the transformation? Reflection in the x-axis. So it's the reflection across x-axis. So you can count the reflection, or you can just take the y values that you already know. We can change the sign so that becomes 5, 0, negative 3, negative 4, negative 3, 0, and 5. Because this y becomes the negative y. Or you change this. And then we have to plot it. So negative 3. And the good thing about plotting the same one over and over again, instead of actually counting each and plotting each point, you can see how they're spaced out and get the reflection. Everybody okay with that? Those are total reviews, right? Okay, so this next one's a review also, but it's not anything that we've done together yet this year. So I've got 2 times f of x. So first of all, is this a change in the x or the y? The y. So the x value is the same. So I get negative 3, negative 2, negative 1, 0, 1, 2, and 3 are still there for my x's. So I'm going to change my y. Remember, whatever happens to y, you do what you see. Okay, so this says 2 times y, basically. So that's exactly what I do. Y becomes 2 times y. So that's going to give me a negative 10, 0, 6, 8, 6, 0, and negative 10. So when you do this, because you're changing y, what's the first word that goes with the description? Is it vertical or horizontal? Vertical, because y is vertical. So it's a vertical what? Stretch, because it's either stretch or compression when you're multiplying, right? And it's a vertical stretch, because when you see y, when you do y, you do what you see. So it's 2 times as much, so we're stretching it out, right? So this is a vertical stretch. By a factor of 2. Which means my x values are the same, I've just stretched it up like it's a rubber band. So then we can plot that. Go to negative 3. I think you go off your graph a little bit. So negative 3, negative 10, 2, 4, 6, 8, 10. Just kind of eyeball it. And then negative 2, 0. Negative 1, 6, 8. And then it's even harder not to make this one look like a V, so let's start by rounding it out right there. If it wasn't so big, I might be able to round it better by just drawing, but it would look horrible. A piece of paper, I could do a little bit better. Everybody okay with that? Okay? When you transform y, you do what you see. Any questions? Because y'all did those last year, right? Total review? Yeah. All right, so now I have this. Here, what's changing, x or y? Y. Okay, so my x values are the same. So it's -3, -2, -1, 0, 1, 2, and 3. So I'm changing y. So I do what I see, which means y becomes half of y. Got to multiply y by 1/2, right? So I can remember what my points are here. That means -5 becomes -2.5. And then 0 is still 0. 1.5. 2, 1.5, 0, and 2.5. Remember, we use decimals responsibly, right? Negative, thank you. I was so focused on, I don't know, gives me a little, decimals stress me out a little bit. But y'all know how to use them responsibly now, right? If it was 1/3, I would want it, it needs to stay 1/3 so you can have it exact, but these are fine. Okay, so this, because I'm changing the y, this is a vertical something, right? So it is a vertical compression, good, because I'm squishing it by a factor of 1/2. Okay, everybody all right with that? And then we plot it. So -3, 2.5. And it should look squished because that's what we're going for here. When they're fatter, it's easier to make them look curvy. Everybody good? Stop me if you have a question because it's a review, so I just kind of assume we're going to get it. All right, so now here, what's changing, your x or your y? Your what? Your x. Okay, so our y's stay the same, so this is going to be -5, 0, 3, 4, 3, 0, -5. Okay. Now, when you change x, do you do what you see? You do the opposite. So technically, the opposite is that instead of multiplying, we're dividing. Okay, so I want you to think about it that way. I don't want you to think about it, instead of multiplying it by 1/2, we're multiplying it by 2. Technically, that's what you end up doing, because when you divide by 1/2, what's 1 over 1/2? 2. It's just 1 over anything is the reciprocal of it, right? Okay, so 1 over 1/2 is 2. So you are multiplying by instead of multiplying, you're dividing by 1/2, right? So we're multiplying by the reciprocal. You're still multiplying, but you're multiplying by the reciprocal. That's the opposite, not dividing instead. All right, I mean, that's one way to think about it, like that's what you're doing mathematically, but the actual rule is that if that is b, then you're still multiplying by a factor of 1 over b. You with me on that? That's technically the rule, and that 1 over gives you the reciprocal there. So either way, yes, mathematically, again, you're dividing by 2 instead of, you're multiplying by 2 instead of multiplying by 1/2, but it's the reciprocal. All right, so x, instead of multiplying x by 1/2, I multiply it by what? 2. So this is going to become -6. -2 becomes what? -4. And then -2, 0, 2, no. Yeah, 2, 4, 6, 5. I've got to have myself there. Okay. So this is changing x. So it is a horizontal what? Is it a stretch or a compression? Stretch. This is a horizontal stretch by a factor of 2, because it is technically 1 divided by 1/2, and that's where the 2 comes from. Okay. We're multiplying by 1 over that number, which is 2. All right, so -6, -5, 2, 4, 6, 2, 4, 5, and then -4, 0, -2, 3. We good? It's a horizontal stretch, right? And if it was 2x, there's not one of those on here. There probably should be. F of 2x, then it would be a compression, right? All right, good. All right, so now we look at this one. What changes here, x or y? What is it? X, right? Okay, so x changes, so y stays the same. So this is -5, 0, 3, 4, 3, 0, -5. Multiplying by a -1. So this is a what? What is this? A reflection in what? Y. So it's the reflection across y-axis. So I multiply all my x values by a -1. So this becomes -x. It's going to be 3, 2, 1, 0, 1, 2, and 3. All right, so 2, 4. Oh, dang it, thank you. Sorry. Just writing stuff down. Thank you. Yes. I was plotting it right. I was not even paying attention to my points. Thank you. What happens when you graph it? Is it a little uneventful? Yeah, does it look exactly like f of x? Does it make sense that it looks exactly like f of x? Yes. Why? Because it's symmetric. Good. It has what kind of symmetry? Y-axis symmetry. And what kind of function is it then? Even. Okay, very good. All right, everybody okay with that? All right, so let's look at this one. And we're going to, instead of coming up with a table of values of this, we're going to use our little rule. So this is the absolute value of f of x. So what is changing, x or y? Y. Okay, and so when you have this, remember your rule is that you keep all of the points where your y is greater than 0. So the points that are the same are these right here in our table, right? And so I'm going to start with, well, we won't even look at that then. We'll just go ahead and plot it. So let's just go ahead and graph just the part where y is greater than 0. So that is this part of the function. Okay? So that part stays the same because y is already greater than 0. The rest of the stuff is hanging down like this, right? So the stuff that where y is less than 0, then it's going to do what? It reflects up in the x-axis like this, right? So if you think about what's actually happening like that, it can help you with your curve too, because you only have one point to go with. This -3, -5 has to become -3, +5, right? So when I go to -3, 1, 2, 3, 4, 5, you got to get your curve going the right way. It's not a straight line, right? And you don't want it curved out the wrong way. If it looks like this, then it reflects up and it looks like this, so it's still curving out like so. And then the same thing happens on the other side. And if you can't get your mind wrapped around like which way it's supposed to curve when you reflect that way, then pick a point in the middle of that and figure out where that was, and you can plot it up here. And then you can get your curve going the right way. If it's a more complicated one where it just you can't wrap your mind around whatever happened, or fold your paper, think about what would happen when it flips up. So we know that all that happened was your y values became positive. So this is -3, -2, -1. Maybe rewrite these so I can make sure I have them right first. And then all of my y values are positive. So this is 5, 0, 3, 4, 3, 0, 5. So let's rewrite this. We're going to keep points where y is greater than or equal to 0. And then all points where y right, where y is less than 0, there we go, where y is less than 0, reflect across the x-axis whenever my pen, y is, okay, I think my computer's doing updates and that's why I can't write. Where y is less than 0, reflect across the x-axis. And I can't do anything on the board now. All right. Any questions about that? We all good? Okay. Go ahead and glue that in. And I'm going to give you a couple of other things before I give you that homework. Okay. Here we go. Let me go ahead and try and finish this up now. Oh, my gosh. All right. Well, this is just being dumb, so...